Okay, welcome back, kiddos. Now we are moving on to 3.5. We're going to talk about parallel and perpendicular lines. Okay, so you talked about parallel lines before. I'm pretty sure you talked about perpendicular as well. So let's get deeper into it as well. And first, let's talk about slope. Okay, so parallel lines we know have the same slope. So let's talk about slope first. Okay, so when we find the slope between 2 points, we're going to use this formula. Okay, so this is what we're going to use to calculate the slope when they want us to calculate the slope. So the y values represent the rise. Okay, the x values represent the run. Okay, so this is going to be rise over run. Okay, so y2 minus y1 will give us our rise. x2 minus x1 will give us our run. Okay, so y value is going to represent that y, and then our x values will represent that. All right, so let's keep it moving. Okay, so the main thing that we need to remember is that x comes first, then y comes second. So the rise is going to be right there, and the run is going to be right there. All right, so let's go with some practice. All right, so we're just going to use this. We talked about how these are the points, right? So it says, what's the slope of a line that passes through these points? Okay, so let's just label the points. We'll say like this is x1, y1, if that's our first point, x2, y2. Okay, so now we're going to say m, which is our slope. Okay, so we're going to use m for our slope. We're going to say is y2 minus y1. So y2 is 7 minus 8. 7 minus 8. So we got to remember that x comes first, then y comes second. Then negative 9 minus negative 6. Negative 9 minus negative 6. Now I could have gone the other way. I could have said 8 minus 7 and negative 6 minus negative 9. Okay, either way, I would have got the same answer. Okay, so it doesn't matter if I say that this is the first point, that's the second, or that's the second, that's the first. Okay, so if we put that into our calculator, we're going to get 1 over 3. Okay, so all we have to do is just type that in. Either we use alpha, y equals, and then enter, or we'll just use the division button on our Desmos. Okay, so that's how we do it. Alpha, y equals, enter. All right, so let's keep it moving. Okay, so on this one, same thing. So go ahead and set this one up. Okay, so we're going to say m equals, okay, so if that's the y, x1, y1, okay, x2, y2, then we're going to say 4 minus 0 over negative 17 minus negative 9. Negative 17 minus negative 9. Okay, so that's going to, or we can, of course, do the other way, right? We could say 0 minus 4 or negative 9 minus negative 17. Okay, so either way, that will give us negative 1/2. All we have to do is just type this or this into our calculator, and it will give us this as an answer. Okay, so that's when they ask for simplest form, we have to reduce a fraction. Okay, so that's what that means. All right, that's it on that. So I do have a couple practice problems on that. All right, next we're going to calculate slope from a graph. So we talked about with 2 points how to calculate the slope. Now we're going to say if we have a graph. Okay, so this is a delta math practice. So we're going to walk through how to do it, how to type it in as well, and then at the end of the lesson we'll go over that as well. Okay, so draw a line representing the rise and a line representing the run. Okay, state the slope in simplest form. Okay, so the first thing we want to do is draw the line representing the x and y. So the first thing we want to do is find 2 good points. Okay, so if we find 2 good points, okay, so the good points are right at where 2 lines cross. That's what we think is a good point. So we can find any two good points. So I like to start right over here, and I just try to see the next good point is. Okay, that is a good point right over there. So we're going to first put a dot there. Okay. Second, let's look for another good point. Okay, that's a good point right there. Right, that's another good point. Okay, so we're going to zoom in. Okay, so we're going to zoom in if necessary. Okay, so first thing we're going to do is we're going to find our two good points. We're going to plot them, plot the points. Okay, so what we're going to do is we're going to click it. Okay, so after we do that, it will allow us to draw a slope triangle. Okay, so what we're going to do is we're going to draw a little triangle just like that. Okay, so third step is draw slope triangle. Okay, so then if we do that, we're going to calculate the rise and the run. Okay, so that's 1. So the rise equals 1, right? Let's calculate the run. Run equals 1, 2, 3, 4. The run equals 4. Okay, so if our slope is equal to rise over run, that means our slope is 1 over 4. And then we need to check if positive or negative. Or negative slope. Okay, so this is going up, so we're going to say that that is positive. So positive because going up. Right, so what we mean is as x is going to the right, y is increasing. All right, so that's it on that. Okay, let's keep it going. Let's go to the next one. Okay, this is the same thing. All right, so first step we're going to do is we're going to find two good points. So what I like to do is look at x and y axis first. Okay, so if we look right over here, that is a good point, right? That's our x-axis, right? And that is a good point, right? This is our y-axis. Okay, let's look on here. That is a good point as well. Okay, so let's calculate our slope triangle, right? We're going to just draw that right there and then draw that right there. So the rise is equal to 1, right? The run is equal to 1, 2, 3, 4. Okay, so we're going to say we plotted our points. We drew a slope triangle. Okay, step 4, the slope is going to be rise over run. So that's going to be equal to 1 over 4. And then the 5, it goes down, so negative slope. Okay, so we have to make sure that we say this is going down because it is negative slope. All right, so we got a couple practices on that. Just go ahead and do those on Delta Math as well. All right, next, now we're going to calculate from a table. Okay, so it's the same thing. What we're going to do is, if this is x and y for 1 point, I'm going to say like that's our point number 1. Right, and then I'll say that's my point number 2. Okay, and so then we're going to just focus on x and y. So we're going to remember it's y2 minus y1 over x2 minus x1, right? So we're going to say y2 is 14 minus 20. 14 minus 20 over 7 minus 3. 7 minus 3. If we put that into our calculator, that will come out to negative 2. Okay? And if we look, it's negative slope, and we can tell as x is increasing, y is decreasing. As x increases, y is decreasing. Okay, so that means it goes down, negative slope. So negative. Okay, let's check this one out. What do we think this is? As x increases, y goes up. So it should be positive slope, right? So we're going to say this is our point 1, right? And we can say this is point number 2. Okay, so let's do it. So we're going to say y2 minus y1, so 8 minus 3, over x2 minus, I'm sorry, not y over 3, right? We don't want to make that mistake. Y2 minus y1, 8 minus 2 over 3 minus 0, right? 3 minus 0. All right, so if we put that into our calculator, that's going to give us the answer of 2. Okay, and that makes sense, right? As x increases, y increases. As x increases, y increases, so positive slope. Okay, so that's something to keep in mind. All right, so now from slope-intercept form, identify the slope and the y-intercept. So the slope, slope is always m, right? And y-intercept is always the b value. Okay, so the y-intercept, we would say we're going to call that y equals mx plus b. Okay, so that's going to always be our slope, right? And then b is always going to be our y-intercept, right? Okay, so wherever we're just going to look in front of the x, right? In front of the x is always the slope. The y-intercept is by itself. Okay, so on this one, we're going to say m equals the number in front of the x, right? So that is 3. Okay, the y-intercept b equals negative 12. Right? B value is the number that's in front of the by itself. Okay, so on this one, m equals negative 1/2. B equals 7. This one, m equals negative 4. B equals 0, right? Because that would be plus 0, basically, right? So on this one, the slope is 1, because there's a ghost 1, right? And the b value is negative 5 over 3. Okay, so I showed you how to get the slope from many different forms. If they just give us 2 points, we're going to use the slope formula. If they give us a graph, we're going to draw our slope triangle and find out. If they give us in a table, we're going to use our slope formula. If they give us in a equation, we're just going to look in front of the m for the slope and in front of the b for the y-intercept. Okay, so now let's talk about vertical lines and horizontal lines. So if we see something like this, okay, this is what we call a horizontal line. Horizontal. Okay, and we can remember horizontal because we can remember hoi. What that means is horizontal lines always have 0 slope, and they always start with y equals some number for the equation. Okay, the equation is always going to be y equals. All right, so then we can remember if this is a vertical line, then we can remember VUX, right? And V stands for vertical. U is for undefined slope, undefined slope. And the equation is always x equals a number for the equation. All right, so whenever we see something like that, this is 0 slope. Okay, and this is undefined slope. So anytime we see a horizontal line, we can say, okay, the equation is y equals. And on this one, it's going to be y equals the y value of negative 2. Y equals negative 2. On this one, it would be x equals where it crosses the x-axis. So right there, x is 3. So the equation is x equals 3. Okay, let's keep it moving. All right, parallel lines and perpendicular slopes. All right, so parallel lines are the same. Parallel slopes are the same. Okay? Parallel lines are two lines that will never intersect. Right? We know they'll never intersect. Perpendicular lines are opposite reciprocals. Opposite reciprocals. Opposite means change the sign from either positive to negative or negative to positive. Reciprocal means flip the number. So make a fraction first if you have to. You're going to make a fraction first if you have to. Okay, and then we're going to flip it. All right, so let's try these. Find the opposite reciprocal. Okay, so opposite reciprocal, we're going to think change and flip. Okay, so we're going to change the sign and flip it. So instead of negative, it's going to be positive. Instead of 1 over 4, it's going to be 4 over 1. Okay, and that also reduces into just regular 4, right? So either one of those would be correct, just 4, right? 4 over 1 or positive 4. Okay, so next, we're going to negative, positive 2 over 3. Instead of a positive 2 over 3, it's going to be a negative 3 over 2. Instead of a negative 5, we said we're going to make a fraction first. So instead of negative 5 over 1, it's going to be positive 1 over 5. So a common mistake would be to say just positive 5. All right, 2 over 1, negative 1 over 2. All right, find the slope of the following lines and then determine if the lines are parallel, perpendicular, or neither. All right, so we need to find the slope first. Okay, so on this one, if we said that's our first point, right, and that's our second point of line 1. So we need to calculate line 1 first, so we can say this is the slope of line 1. Okay, so y2 would be 2 minus 0 over negative 2 minus 2. Negative 2 minus 2. Okay, so if we put that into our calculator, that's going to give us the answer of negative 1/2. Okay, so then this one, we say that's our first point, that's our second point. So the slope of line 2 is going to be 4 minus negative 2, right? 4 minus negative 2 over 4 minus 1. Okay, so if we put that into our calculator, that's going to be negative 6 over 3. Okay, so that's going to be negative 2. I'm sorry, that's going to be positive 2. It's going to be negative, it's going to be 6 over 3. So that's going to be positive 2. Okay, so we have negative 1/2 and positive 2. Well, positive 2 is the same thing as 2 over 1, right? So these lines are perpendicular. All right, and we'll use this symbol right there, perpendicular, because the lines are opposite. Slopes are opposite reciprocals. Okay, keeping going. What do we know about these two? They look like they have the same slope, but let's check. Let's make a slope triangle. This is rise is 2, right? This is 1, 2, 3, 4. Okay, this one is 1, 2. This one is 1, 2, 3, 4. So the slope is rise is 2 over run is 4, so that's 1/2. All right, so that's the same thing, 2 over 4, so that's also 1/2. Okay, so these lines are parallel because the slopes are the same. Slopes are the same. All right, so let's do our last one. It says given this. Okay, so given this, these points. All right, so JK is one line, so that's going to be our first slope. LM is our second one, so let's do that. So we're going to say the JK, so Y2 minus Y1, so negative 4 minus 6 over 10 minus negative 2, 10 minus negative 2. Okay, so if we put that into our calculator, that's going to give us negative 5 over 6. Okay, on line 2, we're going to say LM. So 4 minus negative 2 over 8 minus 3. Okay, so if we put that into our calculator, that's going to give us 6 over 5. Okay, so if we check that out, these are negative 5 over 6 and positive 6 over 5. These lines are perpendicular because the slopes are opposite reciprocals. Okay, so main thing is that we need to use our slope formula, right? Y2 minus Y1 over X2 minus X1. We can actually use it on any of these, but when we have a graph, we can just do the slope triangle, and then when we have an equation, we just look for the X and then just the number itself. When we're just looking at it, we can tell if it's zero slope or undefined. Okay, if you have any questions, just let me know.